Good morning. Let's look at our solutions for 13.5. We want to make the red graph match the blue graph here. What I'm seeing happen is the red graph moved down 1 unit. So if we look at one note, we look at our notes, we look at our transformation notes here, down, right? If it's minus, so f of x, this is up, moving a graph up and down. We're going to add a number after our parent function. So our parent function is sine of x. We're going to add a number to it. So in this case, we're subtracting 1, right? And it's going to go down 1. This one looks like it got taller, right? It went from the maximum height here being 1 to here being 3, the minimum height being -1, and the minimum height here being -3. So it's stretched out vertically, right? It's a vertical stretch. So we know that as a vertical dilation. So that means we're going to be putting a number in front of our parent function, in front of sine x. So we're going to multiply a number times sine x. So what number did we multiply our red function by to get the blue function? Well, it's 3 times taller and it goes down 3 times lower, so I'm going to assume that that means it's 3. Let's see, this one is a little tricky, right? It's kind of hard to see, but if you look at the red function from -pi all the way over here to pi, that's exactly the same shape this blue function's taking, except the blue function just takes longer to do that same arc. It goes from being on the x-axis, it dips down kind of low, it goes through the origin, then it goes up over here, and then it dips down again and stops at 2 pi, whereas the red one goes from -pi to pi. So what happened to the red function that it got stretched out? Well, the height's the same, it didn't get moved up or down, and it didn't get shifted over. We can see that by them having this same origin point here. So that means it's going to be a horizontal dilation. It got wider. And remember, when we do horizontal stuff, it's always the opposite of what we think it's going to be. So horizontal dilation means we're going to multiply the number inside the parentheses of our parent function. So that means we're going to put a number in here with theta. So like, since this goes from -2 pi, or so where it ended at pi, -pi before, now it ends at -2 pi. That makes me think I want to multiply by 2, right, inside the parentheses. But that doesn't do what I want, right? Instead, that does the opposite. Now it goes from this same pattern, starts at -pi/2 and goes to pi/2. Whereas I wanted to go the other direction. I wanted it to take twice as long, not half as long. And so that goes back to the thing we do with horizontal translations for dilations and for shifts is it's always the opposite of what you think it's going to be. Remember, like minus here moves it right instead of left, and here a fraction makes it bigger, and a whole number for a makes it smaller. So makes it skinnier. So we just put in a whole number, right? We put in this 2 and it got skinnier. It squished it in. We want to stretch it out. So I'm going to do the opposite of 2, which is 1/2. The inverse of 2, or reciprocal of 2, I should say. And that is what we wanted. This one, well, this one is same function. It looks almost exactly the same. It's just that everything's been moved over to the right a bit, or I guess to the left, because we were going from red to blue. So everything's moved from to the left this much. See, this one's moved to here, and it's the same amount. It's one big box, right? All the points have moved over this one, like the max here goes from pi/2 to pi/4, 0 to -pi/4, -pi/2 to 3pi/4. It's all one box apart. So it's a horizontal shift. And just like I just said, to shift horizontally, you do the opposite of your expectation, right? So we want to shift left. That means we're going to add. We're going to do plus. And then the distance is just this distance from this point to this point, which is pi/4. So we're going to do pi plus pi/4, because that's the distance here. It's easiest to measure from 0. You could measure from like negative pi over, so let's say that, let's do the minimum point here. Negative pi over 2 to negative 3 pi over 4. This distance is also pi over 4, but it's not as easy to see in these numbers versus when one of your numbers is 0, then the other one's going to be the number you're looking for. Oh, yeah, I think there was an error with 5 and 6 where it didn't actually tell you when you got it. But if it lines up, you got it. So this one's cosine. Change the equation so that the red graph matches the blue graph. Well, once again, this looks like it's just the same function that got moved up. So just like on slide 2, we're going to do a vertical shift of, see, this is at 1, 2, 3, 4, 5. So it goes from 1 to 5. So I'm going to add 1, 5 minus 1 is 4. It might be easier to look at the 0 points, or the center line would it be at 0, and now the center line's at 4. So we're just going to do plus 4. That one might be the easiest one in my opinion. It's just moving it up or down. Change the equation so that the red graph matches the blue graph. So this is just like that last one, right? Except it's the opposite. In fact, we maybe made this graph already. Or maybe it's not exactly the same. But what happened was we have this wider red graph and we want to make it skinnier now. The last time on this one, we wanted to make it wider, right? So we had to multiply by a fraction, or you could do divide by 2 in that case. In this case, we want to squish it in. So we want to do the opposite. We want to multiply by a whole number, a number bigger than 1. So we can figure out what that number is. It goes, so normally to do that first, let's see, what is it? 1. I'm going to look for the first place where I can get like a good. So it goes to a peak, and then a valley, and then a peak again, and then back to the main line, and that takes pi, right? So the red one goes peak, valley, and that takes 2 pi. Let's see, 1, 2. So this isn't really a good number to work with, so that's why I was trying to do that. I think it's going to be 3 because it takes peak, valley, peak, and so it does 1.5 periods, because this would be 1 period, a peak and a valley, and then a peak again in pi. So I think it's going to be 3. Yeah. Let's see. This one is, it looks like from the red one to the blue one, it just got shorter. It's the same function. It's hitting these same points at 0. It's just that the height's different here, the height's different here, the height's different here. So it's a height thing, right? So it got shorter. So that means, remember with the y ones, it's not the opposite of what you think, it's going to be exactly what you think. So it went from 1 to 1/2, so that means I'm multiplying all my points by 1/2. There you go. All right, slide 9. Identify the type of transformation and how it changed. So cosine of theta minus 45. Remember, adding or subtracting inside the parentheses, it moves it right or left. If it's minus, it's right. If it's left, if it's plus, it's left. So this is minus 45, so it's going to be a phase displacement. That's when you move it right or left. And if you needed help remembering that, well, I'm going to say right 45 degrees. To remember which of these is which, you can look on page 5, and it says them all right here. Vertical shift, so this was a horizontal shift because you're adding or subtracting inside the parentheses, and I've got them all labeled in here too, except these say translation. Translation shift, same thing. So this is right 45 degrees. 5 sine theta, so we're multiplying outside of the parentheses. Outside of the parentheses, that means y. Multiplying, that means dilation. So this is a vertical y dilation. So if we want to look at which one's a vertical dilation, it's the purple one, and that is the amplitude. It's the height of the function. Amplitude change, and it's going to be 5 times taller because it's the height. Cosine 6x. So this is multiplying inside the parentheses. So that means inside the parentheses, that means x. That means it's going to be horizontal. And then times 6. Multiplying means it's dilation, not a shift. So we're multiplying times 6, and like we just saw in those last couple, multiplying by a number bigger than 1 is going to squish it in, and multiplying by a number like a fraction is going to make it wider. So squish, so this is going to, we got to see which one this fits though, right? So we said this was a horizontal dilation because it's multiplying dilation inside the parentheses, horizontal. So this is going to affect the period change, and it's going to be 6 times smaller. Let's see, y of sine x plus 4, remember adding outside of the parentheses, so outside the parentheses, that means y, vertical. Plus 4 means shift and not a dilation. So if we're shifting it and it's vertical, it's just a vertical shift. We're moving it up or down. And that's the center line, remember? And if you don't remember, again, that's vertical shift is the light blue, center line right here. So we're moving the center line up, the function up, which means basically just moving the exact same function up, and we're moving it up 4. Cosine 1/3 x. We're multiplying inside the parentheses. Inside means x, horizontal. 1/3, we're multiplying means it's a dilation, so it's a horizontal dilation, as we just saw on slide 11. Horizontal dilation is a period change. And since we're multiplying by 1/3, remember that it's the opposite of what you think. So this is going to make it 3 times bigger, not smaller. And that's when it's inside the parentheses, opposite of expectation. 14, sine theta over 5. This is kind of a weird looking one, but this is actually no different than if we had 1/5 out front times the sine of theta. So this is exactly the same thing. It's just a different way of writing it. Dividing is the same as multiplying by a fraction. So this is multiplying outside of the parentheses. So outside the parentheses, vertical, multiplying dilation. Vertical dilation is the amplitude. It's the height of the function. So this is going to make it 1/5 of the height, or you could say 5 times shorter. If instead of writing it as a fraction, you want to write it as the whole number, the 5, you can just say it's 5 times shorter instead of taller. And then our last one, this one is adding inside the parentheses. And so inside the parentheses is horizontal, that's x. Adding or subtracting, that's a shift. So we have an x shift, a horizontal shift. Horizontal shift is right here. It's the green one, phase displacement. So phase displacement, how did this change the graph? Remember, opposite of expectation, it's not going to move it right, pi over 6, it's going to move it left, pi over 6. And that's all you need for this assignment.